Hey mathematicians, this lesson is going to cover how to multiply and divide fractions. We're not going to delve into mixed numbers yet. That's going to be in a future lesson. But let's go ahead and just go over and review how to multiply and divide fractions. Okay, now one of the nice things about multiplying fractions, as well as dividing, but one of the nice things about multiplying fractions is that you do not have to find an LCD. There's no LCD required one bit. I mean, you could, if you wanted to, you could find the LCD, but it's just going to complicate things if you do that. But really, it's a simple process of just multiplying left to right. That's all you got to do, is just multiply the numerators by each other. 3 times 2 is 6, and then just multiply the denominators, which you don't typically do when you're adding fractions or when you're subtracting fractions, but when you're multiplying them, you can totally do everything here. So 4 times 5 is 20. Now, as with everything with fractions, we always have to make sure that we're reducing and simplifying it down to lowest terms. The greatest common factor of 6 and 20, the biggest number that can divide into both 6 and 20 is going to be 2. So you divide the top and the bottom by the same number. That's how you know you're doing reducing the right way. And then you get a 3 on top, and then you're going to get a 10 on the bottom. And that's as far as you can go. Okay, so you got 3/10 right there. Now, an alternate way of solving a multiplication fraction problem is to do this thing called cross-canceling. Now, with cross-canceling, what you're going to do is you're going to look for common factors that are diagonal from each other. So if you look at the 2 and the 4 right there, is there a number that can divide into both 2 and 4? In other words, is there a number that can reduce 2 and 4? And absolutely there is. You can divide both the 2 and the 4 by 2. So if you do that, then you have to cross that out. That becomes a 1, and the 4 becomes a 2. And now we're ready to solve this. So 3 times 1 is 3, because we multiplied the 3 and the 1 that came from the canceling process there. And then we multiply 2 times 5, which is 10. And that's the same answer we got before. A lot of my students, when we do this, they end up saying, well, is it okay if I don't cross-cancel? And the answer to that is yes, it's fine. Sometimes it does make it a lot easier to get your answer into simplest form when you're all through, especially if you get a really large product. You know, let's say you get really, really large numbers. Let's say you end up getting like 248 over 612 or something like that. And that, you know, not impossible to do, but it gets harder to know, like, what number can I divide these by? And I know you can probably divide by 2, and then sometimes you might miss a number, especially when it's bigger. So it's much easier to reduce the numbers within the fraction than it is to maybe reduce the numbers that are really big when you're done. But it's kind of up to you. But our answer is still, you know, no matter how we do it, our answer is still 3 over 10, 3/10. Okay, with this next example, let's go ahead and just do this both ways to kind of show you what's going on here. Again, you can just multiply left to right. So 4 times 6 is just a matter of, you know, just figuring out what that is, which is 24. And then 10 times 10 is 100. And then it comes down to reducing it into lowest terms. So let's say we don't use the greatest common factor. Let's say we just kind of, you don't have to always use the GCF when you reduce, but it is the faster way to do it. But let's say we only divide by 2. So 24 divided by 2 is 12, and then 100 divided by 2 is 50. And the only drawback to not using the GCF is that sometimes it takes several steps to get it into lowest terms. So again, we can keep dividing by 2 here, and 12 divided by 2 is 6, and 50 divided by 2 is 25. And then we're through, because 6 and 25 do not have any common factors. So that's your answer in simplest form right there, 6 over 25. Okay, now let me show you guys the cross-canceling method. And for this one, again, we're going to look for numbers. Now, here's the thing I think some people get hung up on with cross-canceling is that they think, well, 6 isn't a factor of 10, which is true. 6 is not a factor of 10, but that's not really the point of cross-canceling. The point of cross-canceling is that you divide both those numbers by a common factor. So the number that you can divide 6 and 10 both by would be 2. So you can divide those both by 2, and so that becomes a 3, and then 10 divided by 2 becomes a 5. So see, we didn't have to reduce by or simplify by one of the numbers themselves. It just had to be a number that divided into both. Same thing applies to the other pair of numbers that are diagonal from each other, 4 and 10. You can divide those by 2. So 4 divided by 2 is 2, and then 10 divided by 2 is 5. And now we're all ready to solve this. So if we just multiply left to right, we're going to do 2 times 3, and then we're going to do 5 times 5. I'm just kind of doing this just to clean it up. Sometimes I think it's hard for people to see what's all left there. But that's what we're doing. So 2 times 3 is 6, and that's what we got before. 5 times 5 is 25, and that's also what we got before. So 6 over 25 is our solution. That's with cross-canceling. And while I'm thinking of it, another thing that you could do when you guys solve this problem is that if you look at the fractions themselves, 4 over 10 and 6 over 10, those fractions by themselves can both be reduced. So you can reduce those fractions, as what they are. So 4 over 10 can reduce by 2, so you end up getting 2 over 5, 2/5. And you could do the same thing with 6 over 10. So you can reduce by 2, and you get 3 over 5. And look what happens. We end up getting the same product. 2 times 3 is 6, and 5 times 5 is indeed 25. So we got 6/25. So there's there's a lot of different ways you can do this. You can do no cross-canceling whatsoever. You can cross-cancel, or you can just reduce the fractions themselves. Now, a lot of this stuff that I'm showing you, and this is a biggie. Now, the thing is that I always have to kind of give a little bit of a caveat or a warning here about what's going on, but cross-canceling, after I teach cross-canceling, I always have to remind my students that it does not work when adding or subtracting fractions. The cross-canceling, especially when you're talking about the diagonal, if you're looking at those factors, those common factors that are diagonal from each other, cross-canceling is not something that you can do with adding or subtracting. It only works with multiplying fractions, and that's it. So keep that in mind. That is a biggie. And again, there's a lot of little rules in mathematics, but again, that's where practice comes into play. If you practice this enough and you get these rules kind of embedded in your brain, and you won't forget them. Now let's quickly go through some examples here where you're dividing. Okay, so the directions here say that it's easy. It's, turn the second fraction upside down, which is called the reciprocal. I've had some people call it the reflipical, which is, I think, kind of a clever way of calling it that. Maybe some of their elementary school teachers called it that, and I think that's a really good way to kind of remember it. But reciprocal, reflipical kind of rhymes, makes sense. But the important thing that when you're dividing fractions is that you need to find the reciprocal of the second fraction. So you got to rewrite it. That's one of the things that you kind of have to get used to in mathematics, is that there's a lot of rewriting of the problem. So you got 3/10 times 2 over 1. So we flipped that second fraction. Okay, and at this point, it's okay to cross-cancel if you want to. All right, it's very important. All right, that you know that you can cross-cancel. You cannot cross-cancel when division is presented. You can only cross-cancel, and again, I'm going to use some of my past students. They have used these as pointers. I know that's an X, but some people call it a cross. And some people say, well, don't cross-cancel until you see the cross, the X. X is kind of a sideways cross, of course. And that's a good way to remember it, I think, because then you can cross-cancel the 2 and the 10 by dividing by 2. So 2 divided by itself is 1, and 10 divided by 2 is going to be 5. So if you do the math there, you got 3 times 1, which is 3, and then 5 times 1, which is 5. So you got 3/5 right there. And in this last example, I'm going to show you just going through just repetition here. Make sure you guys know how to do these. This one comes with another thing too that I've learned through the years, which this is a good little rhyme. Flip the second guy, then multiply. That's what I've heard some students say before. Flip the second guy and multiply. That's a good way to think of it. So we're going to do 4/10. We're not going to flip 4/10. We're going to leave that the way it is. And then we're going to change division into multiplication. And then flip 3/5 to 5 over 3. And again, like I was saying before, it's okay at this point to cross cancel. So if you look at the 5 and the 10, you can both divide those by 5. So 5 divided by itself is 1, and then 10 divided by 5 is 2. 4 and 3 cannot cross cancel. And then you can multiply. So 4 times 1 is 4, and then 2 times 3 is 6. Now you might notice at this step right here, we can still reduce. So why didn't cross-canceling handle all the reducing? Well, it's basically because right here, if you look at this, essentially we have 4 over 2. Now that fraction, if you think about it, 4 over 2 can reduce to 2 over 1, right? So I wouldn't worry too much about getting all the cross-canceling completely finished and all the reducing done. But when you're done, don't always assume that it's in lowest terms. So if you divide 4 and 6 by 2, you end up getting 2/3, and that's the answer. Okay, that does it for multiplying and dividing fractions, everybody. Make sure you go through the practice problems that accompany this lesson, and you know what you're doing before you move on to multiplying and dividing mixed numbers. Okay, everyone have a great day. See you later.